Welcome to Automation Studio. The following demonstration shows how quick and easy it is to design and simulate circuits. In this example, a hydraulic circuit can be built simply by dragging and dropping components from the library onto the diagram. To easily distinguish between active components, notice that when a component is selected, it is highlighted in blue. All available ports or connection points appear in red. To connect the components, place the cursor over a port. Click and drag to the next connection. Once a connection has been made, the ports change from red to black. The cursor always changes from an arrow to a target symbol whenever placed over a port. To graphically change the appearance of components, simply select and drag its borders until the desired size is achieved. The component easily snaps onto the existing connection line. The orientation of the object can also be flipped or even rotated with the click of a mouse. Notice here again that even though connections have already been made, additional components can still be added into the circuit without having to delete and redraw the lines thanks to the snap property. In just a few minutes, a hydraulic circuit was built quickly and easily by clicking, dragging, and dropping components. Let's take a moment to examine the component properties, which is accessible by double-clicking on a symbol. As you can see, basic data is automatically assigned, but can be changed along with the units. Advanced data is also provided. Driving force and resistive force curves are also accessible if a user wishes to set variable loads on a cylinder. Catalog information allows the user to assign information about the part based on selected fields. The information can also be retrieved by clicking on Find Part if a client has already uploaded their catalog database. Accessories can also be added in the same way. Displayed information lets the user decide what will be displayed on the diagram. Let's select the component's name and the piston diameter to be displayed. As you can see, these identifiers, also called satellites, can be placed anywhere the user wishes. The builder allows the user to design or customize the component based on its functionality requirements. Sizing sheets are also provided so that complete component parameters can be used for advanced calculations. Equations are also readily available, serving as a quick reminder as to how data was calculated and saves time from having to retrieve information from other reference books. Equation sheets can also be printed. Next, we will examine the valve and its builder function. This allows the user to select the number of ports, the initial position, and the number of positions. Double-clicking on the lever shows all other available controls. And the arrow buttons above make it possible to change its location. Double-clicking on the spool shows the other possible configurations to choose from. For the pump, we will look at the characteristic curves, which allow the user to modify the pressure and flow parameters simply by clicking on a point on the curve and dragging it to the new value. For greater accuracy, data can also be manually assigned in the table as well. Choosing Reset restores the original value. Apply uses the last value assigned. The pump's sizing sheets also allows the user to modify other parameters as needed. Next, let's examine the accumulator. To achieve specific results, we can assign a pre-charge value. We can even change the properties of the pressure lines as well. Now, before simulating the project, the plotter is pulled out. And the components that we wish to monitor are selected and dragged right onto the graph. A unique color is assigned to each parameter that we wish to measure. The minimum and maximum values of the scale can be changed, as well as the time scale. And now we shall simulate the project by clicking on the green Simulation button. The dynamic simulation allows the user to model the behavior of the circuit based on the assigned parameters. Clicking on the valve causes the cylinder to extend or retract. Clicking on the cylinder and selecting Animation shows a cross-sectional view of what is happening inside the component and is synchronized with the simulation. Double-clicking on the relief valve allows the user to modify the cracking pressure and instantly observe its effects on the rest of the system. Once simulation is complete, the results of the plotter can be exported to a spreadsheet or transferred to a text file. You have now seen briefly how Automation Studio can quickly and easily design, simulate, and model a circuit. We hope you have enjoyed this overview. For further information, please visit our website at www.automationstudio.com. Thank you.